Hello there, this is Ashraf from Xenon Studios. Today I want us to discuss the concept of a cycloid. Now a cycloid is this is a path that is traced out by a point on a rolling circle. Now we are drawing the path here is going to be flat, and we actually want this circle to roll along this flat surface. Then we want to trace out the path that is traced out by this point that I've just inserted down here. So we want to know if this circle rolls to the next position, what will happen to this point. Of course, this point will also change position because this point is attached onto this circle. So as the circle rotates, or as the circle rolls along this surface, this point will move, and want to roll this circle for one complete revolution and see how this point will also move. We want to trace out the path of that point. So to do that, I want to bring in something to help guide us. So yeah, perfect. So as you can see, this guy Luvega Ashraf wrote something good here. He said to plot the locus of a point moving on a circle, let's borrow knowledge from the circle moving on a flat surface. Okay, so we are plotting the locus of a point P on the circle. So point P is down here. Perfect. So if we move to the next page of his book, we see that he says once the circle moves to position M, as you can see we have the position M right here, you realize that point P is displaced to a new position on the circle. Point P is moved by a distance r on the circle. This means that this point P is actually going to be moved by a distance of r, this ordinate distance, by distance r to this one here, to this new position here. So if the circle rolls to the first position M, the point P is moved along the circumference of this circle to a new position, this one. And if the circle moves to the next position N, the point P will be displaced by a distance of 2r to this new point, to this new position here. Okay, let's read on. When the circle moves to position N, this one, point P is moved 2r on the circle, that is along the circumference. Once the circle moves to the next position, point P will be at 3r on the circle. As you can see, the next position is here, and point P will be 1r, 2r, and 3r here. So the same pattern continues for a full reversion as shown. That is r, 2r, 3r, 4r, blah 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 up to 12r. And that is how we can trace out this locus here. So if we go back into AutoCAD, I'm going to draw a line. Okay, let me draw a line just exactly there. Now my circle here has a radius of 25, and if you divide the circle, into 12 parts, the ordinate is actually going to be 13. Okay, let me draw this circle out. It has a radius of 25. I'm going to divide this circle into 12 parts, hit enter, and if I'm to measure this ordinate right here, you see that it's actually 13. So that means I need to roll out the circumference of this circle here on this line. So I'm going to divide this line into 13. So I'm going to draw an arc that is actually 13. Hit enter, control, like that. So grab that and copy. That is 2, 3, and that is 4. So I'm simply going to select these, copy, and copy them 3 times. So this is 2, and this is 3, so those are my 12. This is the circumference of this circle laid out on this line. So perfect. So the idea is that this circle is going to roll to this new position here, 1. And by the circle rolling, that means the point here will also change because the circle has now moved. So perfect. So what I'm going to do, I'm going to grab this circle and I'm going to copy it to my new position here. But as you know, we've just copied, but in real life this circle has to move. So I'm going to select this circle, say rotate. I want the base point to be the center. Then I want to use a reference. Still I'm using the center like that. Then I want to rotate it like that. Perfect. So by the circle rotating to the new, by the circle rolling to the new position, the point has also moved by distance 13 along the circumference of the circle to that new position. And then if this circle again moves to the next position, which is this, okay, that means I need to also rotate this circle. I need to use a reference. Still I need to use the center here. Perfect. As you can see now, the circle has moved to the second position, and that means the point has also moved by 2r. What do I mean? It has moved by an ordinate distance of 26 along the circumference of the circle. I don't know if that makes sense, but if you've done this before, I'm sure you're getting the whole idea. And this is what we are going to do for the whole revolution of this circle. So I'll move this. And it will be right there. So if I'm to draw the spline, I'll simply join these points here. So join these points up to here. So hit T, enter, and that is just half the cycloid, so you can simply mirror this to the other side now. And this is our cycloid, just like that. Now there is another way of doing this. So come over here, draw your circle, radius 25, hit enter. I'm going to draw a line here, just like that. Then you remember our arc length there was 13, so I'm going to divide this. Okay, let me first divide the circle into 12 parts, enter. Then I'm also going to divide this length here into segments of 13, just like that. Then all I need to do is to draw lines just like that. So I'm going to copy that line to all these points. Like that. Perfect. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Perfect. Then I need to also draw horizontal lines that go through from these points to the other side. So these will be my horizontal lines, just like that. Just like that. And finally I could simply select these lines and mirror them to the upper side. Now, perfect. So I can now draw in here my cycloid. How do I do that? So I'm simply going to let me name this figure. For purposes of time, I'm simply going to grab all these numbers up here and copy them. So I'll delete it. Perfect. So what you do is you're going to grab your arc tool. I prefer using center start end, and then you're going to stand at the center of the circle. Then you're going to draw an arc here at the 0 point here, and it's already there, so no point in doing that. So I'll head over to 1, and then I want to draw a line on the line. I want to draw an arc on the line from point 1 using the same radius as my circle, and that is 25. So you come out a little bit like this, then you're going to insert a radius of 25, hit enter, and then you're going to draw an arc just like that. Now my arc has gone berserk, so let me redraw it. There, zoom out, you're drawing an arc onto the line from point 1. So, and that is it. So you're going to put a point right there. So grab your point and put a point here. Perfect. So go to the line at 2, grab the arc, go to this point 2 here. Then you want to draw an arc at the line from line 2 still, and the same radius 25. So input 25, hit enter, and draw an arc just like that. Then grab a point and put a point right there. So you're going to do that for points 3, 4, 5, and 6. Perfect. So I'm going to come and grab my spline, start from there, head over to this node, then to this node, then to this node, then here, then there, then there. Then I'm going to hit T because I want to stop here. I will simply mirror this to the other side. I'm going to make this thicker, and I'm going to simply mirror this because this is symmetrical to this other side, and there we have our cycloid. Perfect. That's all from me. Thank you for watching. See you in my next tutorial.